was looking at what you were doing, I saw that most of you were using the method that I used to prove the two triangles, to prove the law of sines, which will work. You can get the answer that way. It's just a lot more work than you need, okay? You're going to have to do a lot more work than if you use the law of sines. So let me show you how to use the law of sines, okay? First of all, I know that this angle up here is 122 degrees. I know that this angle is 40 degrees. Now, and I know that this side is 10, right? Now, you guys, if you know two angles of a triangle, do you know the third angle? Yeah. What is the third angle? 18 degrees. Okay, carefully watch this, you guys. Some of you didn't get this. First of all, just so you know, the law of sines can be written like that, or you can flip-flop it. You can write the sine of angle A over A is equal to sine of angle B over B is equal to the sine of angle C over C, okay? You can write it either of those two ways. Now, it depends on what you're solving for, which way you're going to use it. If you're solving for a side, you want the sides on top. So we're going to want to use this one right here. If you're solving for an unknown angle, you want the angles on top. The reason why is because it just saves you a step. Now, you don't have to have it that way. It will just save you a step. And it doesn't matter. Either way is equivalent. Okay? Okay, so what I want you to see right now, we know angle C and side C. We know them both, right? So that is the ratio I'm going to use. So I'm going to use this one right here because I know both the side and the angle. So I'm going to go side C, which is 10, over sine of angle C, which is 18 degrees, equals, and it doesn't matter. Do I want to find side A or B? A. Okay? So I'm going to find side A over sine of angle A. Angle A is 122 degrees. So now I have an equation with one unknown in it, side A. And that's what I'm going to solve for. So how do I go about solving for that? I multiply both sides by sine of 122. Because over here they're going to cancel out and I have A by itself. So A is equal to 10 times the sine of 122 degrees all over the sine of 18 degrees. Put in your calculator. Tell me what the answer is. By the way, if you come up with a different answer than everybody else, you might want to check your mode. What? 27.44? 443? Does everybody agree with that? Okay. See if you guys can find side B using the same method. Okay? I'm going to give you 30 more seconds. Okay, so we got 20.801. Raise your hand if you did not get that. Okay. There. Yeah, well, at the end of class, if we have time, listen and we'll have time. If you don't listen, it takes me long to get through it. You won't have time. Okay, most of you guys got this written down. Let me ask you this. When do we use the law of sines? By raise of hand. Who remembers? Rebecca.
Not a right triangle.
When it's not a right triangle, and what else? You have to have two angles and a side. Okay? Yes. Well, that was only to derive the formula for the law of sines.
Well, how come for all those other ones where we with the little right triangle?
Yeah. Okay. Hey, you guys. That's a good question. On that worksheet that we're going to be turning in at the end of class today, the one that we did last time. Okay. It was. They just put it on my desk. Yeah, that's important. Thanks. Okay. That worksheet we did last time. If you would have had the law of sines when I gave you that worksheet, you could have done the last two problems a lot faster. You know how you had to use right triangle trigonometry? We had to draw on that extra line, and you had to figure out, you had to do like 4 or 5 calculations of SOHCAHTOA before you got the answer. Well, if you would have had the law of sines, you wouldn't have needed that, and you could have done a lot faster. Now, Drake asked the question, why aren't we going to use the drawing in the line, making two right triangles and doing that? Because you have to do more calculations that way. If you use the law of sines, you can skip most of those and you can go right to it and get the answer. Okay? So the law of sines just makes it faster. If it's not a right triangle, the law of sines and law of cosines is going to be faster. Okay? And so that's what we call them. We call them oblique triangles. Non-right triangles are called oblique triangles. And we only use the law of sines under these three circumstances. When you have two angles and a side, like angle, angle, side, or angle, side, angle, or this is the only case we use them if we have two sides, if we have side, side, angle. Now, you guys remember, angle, side, side is the same thing as side, side, angle, but I like to write it this way better for good reason. All right, so I don't get fired. Okay. So anyway, you guys remember from geometry that you can't prove two triangles congruent that are side, side, angle. Remember that? And because it doesn't always make two congruent triangles. Today I'm going to show you why we call this the ambiguous case. Because sometimes it doesn't form a triangle. Sometimes it forms two different triangles. Okay? If you're given this information. I'll show you why when we get there today. So the only time you're going to use law of sines is when you have two angles and a side, or side, side, angle. You use law of cosines, which we'll talk about next time, when you have side, 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 or side, angle, side. Got it? Okay? You have to have at least one side to solve it. That's not enough information to solve it. If you have angle, 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 you need at least one side. Okay? All right, so you guys knowing what you know now, where I showed you, see this problem right here? I am going to give you 3 minutes to solve this. I'm timing you. Go. Okay, how many of you guys set it up this way? And all you have to do is multiply both sides by 8. Those cancel out. And I have sine of C equals 8 times sine of 80 over 12, right? But I don't have C isolated. I have the sine of C isolated. How do I isolate the C? Not divide by sine. Someone said it. Inverse. I'm going to take the sine inverse of both sides. So I get C equals, wow, C equals the sine inverse of 8 times the sine of 80 all over 12. And what did you get, Zach? 41.0 what? Degrees, right? So there's my answer for that C. Once you know two angles, you get the third, right?
Yay! We did it!
What is this one? And then I can use, hey, by the way, you don't want to use C's to solve this because that's an approximation. So what you want to use is sine of 80 over 12 equals, or actually you want to do it the other way. You're looking for a side, so you want the sides on top, right? 12 over the sine of 80 equals A over the sine of 58.964, and you got that answer. What did you guys get for that one? 10.441? Okay, any questions there? Did you use an approximate? Did you round it differently? Did you round this different? Then you got to divide it by whatever. Okay?
58.964 times sine of that times.
Over the sine of 80. Divide by the sine of 80. Colby.
I got the right thing. What you have to do is you have to do the sine of 58.964, right?
What do you have? A over the...
That I opposite over adjacent. So sine.
Did you get the...
I got all that right. That's not the wrong part I got. I did the sine. So opposite over.
Oh, yeah, you can do that, but that's an extra couple steps. Yeah. Well, are you talking about opposite over adjacent using these figures?
Using 58, whatever.
Well, this is not a right triangle. You can't use SOHCAHTOA. Yeah. Yeah, this is not a right triangle. You can only use... That, hey, you guys, that happened in my other class a lot, too. You can only use SOHCAHTOA on right triangles. Okay? You can only use SOHCAHTOA on right triangles. Hey, you guys, right here, the book divides this up into 2 lessons, this law of sines. So I've got 4 problems on page 316 and 2 problems on page 324 I want you to do. Okay? Page 316 I got 4, page 324 I got 2 problems I want you to do.